OSI reference model, basic of layered structure. To understand the complex process of network functionality, the Open System Interconnection, OSI, reference model has developed. Draft published by OSI, International Organization of Standardization, in the year of 1980. It defines on ISO IEC 7498. The Open System Interconnection, OSI, reference model provide the guideline how two devices are communicating. It is just a theoretical reference model. It does not provide the technique how actually communication happen. It has 7 layers and each layer function are well defined. It uses generic protocol to describe the function of each layer. Protocol means to communication over network. It follows a procedure that computer must be understand, admit, and follow. While two-person communicating each other, they must be use common spoken language to understand each other. This rule similar to the protocol. Example HTML, SMTP, UDP, TCP etc. OSI reference mode is protocol independent. Protocols are created based the function specified in each layer. Data should flow layer by layer. Sending computer, flow the data from upper layer to lower layer, that is, down the stack, and receiving computer flow the data from lower layer to upper layer, that is, up the stack. It is used to standard compression with other models such as TCP/IP model. The 7 layers refer to as a network stack. The 7 layers are as follows. Application layer Layer 7, Presentation layer Layer 6, Session layer Layer 5, Transport layer Layer 4, Network layer Layer 3, Data link layer Layer 2, and Physical layer Layer 1. In application layer, user application software interact with application layer. While user surfing internet on browser, read a mail on Outlook, it interacts with application layer. It is responsible for to identify the communication partner, resource availability, and user authentication. Example of application layer protocol, X.400 X.500. The function of presentation layer is encoding decoding, that is accept the data from application layer and encoded it such a standard format so that other end receiver application layer can understand. It converted the user language to machine language. In receiver end, it again converted from machine language to user language. It also used for encryption and decryption. It converted the data is such a format so that user sensible data privacy can maintain. In receiver end, data has decrypted. Compress and decompress is another function of this layer. It helped to reduce the size while sending the data. In receiver it converted to original size. Example of presentation layer protocol are ISO IEC 8823 X.226. In session layer, accept the data from presentation layer and it establish, maintain, and synchronization while communicating of two system. Allow system to enter a dialogue. It either half duplex mode, that is one-way communication, or full duplex mode, that is both-way communication while communicating. It allow to add checkpoint on stream of data. Suppose we are sending a file of 1500 pages and after every 100 pages have one checkpoint so that it is ensure every 100 pages are received and acknowledged. Suppose page 350 has crashed. So only 301 to 350 pages are need to be resent. There is no requirement to resent the page from 1 to 300. Example of session layer protocol are ISO IEC 8327 X.225. Transport layer is responsible for delivery the date from one device to another and maintain the quality of service. Also control the connection and flow. There is two type of connection, that is connection-less and connection-orientated. In connection-less, sending the data best effort basis. Here there is no acknowledgement or error checking. UDP is used for this purpose. In connection-orientated, provide delivery acknowledgement, error checking and recovery procedure. It cuts the data into small pieces is called segmentation, and sequence number assigned against each segment. TCP is the use for this purpose. It manage the end-to-end flow control while transmitting on network. Example of transport layer protocol TP0, TP1, TP2, TP3, TP4. Network layer is responsible to send the data to specific destination. Accept the data from transport layer and add the header contain source and destination logical address. After adding header with data is called packet. If data is too large, then it fragmented at source end and defragmented in destination. Data link layer is responsible for end-to-end data transfer. It detect and correct the error which occurs during the transmitting over physical media. It converted into binary. In physical layer, received binary converted into electrical signal and make suitable transmission over media.